All right, this is section 4.4. We'll start with the warm-up. All right, we're talking about polynomials. So there are some important terms that we can go over. Polynomial terms. Leading term, I'm going to write them all down and then I'll define them. Leading coefficient. I'm writing fast, but you can always slow this video down. I'm going to try to upload it to YouTube and you should be able to slow it down to half speed or whatever. Polynomial degree. We usually don't write the word polynomial, we just write degree. What's the polynomial degree? Those are the three I see on this page. So the leading term is the term with the largest power of x. So if I have a function f of x equals 7x to the fifth minus 3x squared plus 4, the leading term is that whole term, the 7, the x, and the raised to the fifth. The leading coefficient is a constant that is multiplied in the leading term. So in this case, it's the 7 that goes with the 7x to the fifth, and the degree is the power on the x in the leading term. So right there is the degree. Let's do one more. I have g of x. Let's say it's 2x to the fourth minus 3x squared plus 5x to the sixth minus 4. You have to be careful. This is not the leading term. It's the first term, but it's not the leading term. The leading term is the one with the highest power. So it's 5x to the sixth. The leading coefficient is the 5, and the degree is the 6. So often what you're going to want to write, or you're going to want to do, is just rewrite it so you have largest power to smallest power. So that can be the first step. Your first step is to make sure your polynomial is written from the largest power, working on way down to its smallest power. And remember, constant comes at the end because it's like x to the 0. All right, let's give an example of a polynomial with degree 6 and leading coefficient. I know my handwriting is terrible, but I don't care because I'm doing this for all of you guys, and I hope it's helpful. Leading coefficient of 1/3. I'm going to give the simplest one I can think of. F of x equals 1/3 x to the sixth. I don't have to write anything else. That's a polynomial. The degree is 6, and the leading coefficient is 1/3. I could add a bunch more smaller terms on here, smaller in terms of powers, but I don't have to. All right, moving on from the warm-up. Looks like there's more stuff to the warm-up. Usually I don't go through each question. Now I'm looking at this. I think I can make this work. All right, so end behavior of polynomials. This is 4.4 warm-up questions 3 through 6. We basically have 4 types of end behavior. So if I draw my axes first, and I draw all 4 different axes just to get them all on there, we can have goes up as you go to positive infinity, goes up as you go to negative infinity. We could have it start down at negative infinity and up positive infinity. We could have it go down on each side, or we could have it start up and end down. So this one is x squared. I mean, there's might be a lot of stuff in the middle, but remember what I said, cover it up and just look at the ends. Yeah, that looks like x squared. This one looks like x cubed. If you cover it up, that looks pretty much like x cubed. This one looks like minus x squared. And this one looks like minus x cubed. So any polynomial, no matter how much is going on, is going to end up, when you get far enough out, looking like one of these four. So if I write a big long polynomial, let's do 3x to the fourth minus 2x cubed plus 7x plus 1. I don't know exactly what that's going to look like, but I know the leading term is positive and the power is even. So if I raise anything to even number, to an even power, it's going to end up positive, and multiplying it by a positive. So that all works together. And so it's going to end up going this way and going that way. There's going to be a bunch of stuff in the middle. Maybe it crosses a couple times. Don't know for sure. But I know the end behavior is going to look like the end behavior of x squared, even though this is kind of stretched out. I'm not going to go through the other three possibilities with example graphs or example functions, but you will be doing that in your warm-up. Moving on. Okay, more end behavior. Let's just do another one. So this is 4.4 in the workbook. Question 1. More end behavior. We just looked at something that looks like x squared, so now let's look at something that looks like x cubed. So if I have a polynomial function, x to the 7th minus 2x plus 4, I think, is that power even or odd? That's odd. And is the leading coefficient, which in here it's a 1, is that positive or negative? It's positive. So I know it's going to look like x cubed, which has an odd power and a positive coefficient. So it's going to, at the end of the day, it's going to look like this in its end behavior. There might be a lot of business going on, who knows, but it's going to end up looking like that. That basically takes us through question 1 and question 2. Question 2 is more of the same, maybe with some different comparisons, but it's all just looking at leading terms. I will point out, just to remind you, if I have a function that looks like this, and I ask you what's going on, what's the end behavior like, don't just look at the first term, you have to look at the leading term. That's an even power, so it should look like x squared. That's a negative leading coefficient, so it should end up down. All right, moving on. Question 3, 4.4, question 3. Sometimes we have polynomials that are written factored. Let's look at x squared times x minus 1 times x plus 3 cubed. I'm making up all of these off the top of my head, so if we run into problems, we have to deal with it. I could multiply all of this out, but that's a lot of work. So instead, I'm just going to look at what's going on in the powers. I have a second power, a first power, and a third power. So if I were to multiply all of this out together, at the end, I'd end up with a 6 in my power. And then I can look at the leading coefficients. That one's a 1, that one's a 1, that one's a 1. And so the leading coefficient is a 1. So this f of x has the same end behavior as x to the sixth, which is x squared. Now let's do another one. This time, that. And so first I look at the powers. There's a 2 and a 3. So I know my polynomial is going to behave like x to the fifth. I look at the leading coefficient, which is a -3. So it's going to behave like -3x to the fifth plus other terms. So its end behavior looks like negative x cubed. Negative leading coefficient, odd power. All right. Where are we? Is this 4.5 or 4.4? I think that's the end of 4.4. It is. Okay. I will end the video then.